Welcome to KIT203 ICT Project Management and Modelling. In this short video, we're talking about estimating costs. This is the contents of this video. We'll talk about estimating costs, schedule-driven cost estimation, algorithmic cost estimation, various forms of COCOMO, and cost drivers. With projects, we don't really know what they're going to cost. We need to make estimates so that we can charge enough to make money, but not so much that we can't get a contract. And there are lots of different types of cost estimates. A rough order of magnitude is appropriate early on in the project, but they're not very accurate, but they do let you work out which projects should be selected and which shouldn't be. Budgetary estimates are still quite early on in the 1 to 2 years before the end of the project, and these tend to be more accurate because money will actually be put aside following these estimates. And the definitive costs tend to occur once the project is underway and on its way to being finished. It works out what the final purchases and actual costs will be, and these tend to be pretty accurate. The number and type of cost estimates vary depending upon what you're doing. Estimates are usually done at various stages of a project and should become more accurate as time progresses. A large percentage of total project costs are often labour costs. There are a range of cost estimation tools and techniques, and we'll look at them in more detail, but broadly, the analogous or top-down estimate uses the figures from a similar project and bases the current cost on that. Bottom-up estimates work out what each task would likely cost and then adds those task costs together. And parametric modelling does some mathematical magic to work out the likely cost of a project. But there are some problems that are common to estimating costs. Estimates are done too quickly, people lack estimating experience, human beings are biased towards underestimation, and management desires accuracy. And we can't keep everyone happy with all of these problems. Schedule-driven budget estimation is a bottom-up method of estimation. The idea here is that we have already developed a schedule and we know what resources we have available to complete each task, and we call that the baseline. It's something that software management tools can do really easily. And on the surface, it all seems very easy. You work out what resources will be needed for each task, and then what each resource costs, and the fixed costs, press the button, and it's all done. However, there's more to it than that. Resource costs can come at different times in a task. Resource costs different amounts at different times. The law affects what you can do, and there are some accounting rules that will impact everything too. It seems simple, but it's not. So look at this. We have all these staff. Some of them are working full-time on the project, others have other duties. They have different standard rates and overtime rates. Harry has a cost per use. Sam, Charlie and Ava are paid for the amount of work that they've done in every period, but Joseph is not paid until the end of the project, and Harry needs to be paid before he gets out of bed. Suddenly everything becomes more difficult. However, even though it's very difficult, it's considered to be the best way of estimating costs. Algorithmic budget estimation is the second best estimation technique after the schedule-driven estimation. The algorithmic estimation takes some measure of the size of the problem and applies on it an algorithm to arrive at the budget for solving the problem. The lines of code value relates to the number of thousands of non-comment source statements in the program. The lines of code variable is shown in formulas as KLOC, 1,000 lines of code. KLOCs are one of the most detailed sizing information possible and can potentially lead to the most valuable budget estimates. However, in modern software production, which favours code generation and code reuse, it's very hard to estimate lines of code and distinguish them from reused or generated code. Function points give less detail about how much work needs to be done, but they're still useful. We're not talking about counting actual functions or methods. We look at inputs and outputs, data files, inquiries, and external interfaces. Then we decide how many of each of them we need and how complex we think they would be. Object points are even more general. We're counting things again, but in this case we're counting features, user interface screens, software reports and software components. We adjust the calculation with weighting factors to reflect features complexity. The calculation is also adjusted to remove reused object points. This leads to the measure called new object points, or NOPs. Another algorithmic estimation method is called COCOMO. It has the underlying formula where effort is equal to C and size to the power of K. C is a constant that's decided based upon how reliable the product needs to be, how skilled the team is, and what tools are available to help. K is another constant which considers the complexity of the project. COCOMO is the constructive cost model, COCOMO, and the original model was COCOMO 81 because it was developed in the 80s. COCOMO 2 was developed in the year 2000 and is better. COCOMO 81 has 3 levels. Basic COCOMO, which is basic. It's good for the rough order of magnitude estimates, but it shouldn't be used later on in the project where accuracy is more important because it doesn't include the cost drivers. Intermediate COCOMO does take the cost drivers into account, and detailed COCOMO also considers how difficult different phases of the project are. Basic COCOMO comes up with a single value based upon the 2 constants and the estimated number of lines of code. It applies to organic projects that are small and simple and that the teams are skilled and the requirements are flexible. It also applies to semi-detached projects which are medium-sized with mixed levels of skill and some flexible and some rigid requirements, and the embedded projects which have strict requirements for everything. And this is how you calculate basic COCOMO 81. It's on the slide. If you want to use it, please look it up. For intermediate COCOMO, the cost drivers are considered by rating 15 different attributes on a 6-point scale. These result in an effort adjustment factor of between 0.9 for easier projects and 1.4 for more difficult ones. And these are the cost drivers. They describe the product, the hardware, the personnel, and the project. If you have a look at some of them, you can see that these could have an effect on the cost of the project. And these are the effort multipliers for just one of those factors, the complexity of the product. By multiplying all of the effort multipliers for our project, we get an effort adjustment factor. So when we're doing intermediate COCOMO, we use that effort adjustment factor in the new formula. And this time we're using the coefficients A and B instead of C and K. With advanced COCOMO, it applies the effort adjustment factors to both the analysis and design phases, not just the programming phase of the project. COCOMO 2 is based on the same principles as COCOMO 81, but it addresses a couple of important COCOMO 81 deficiencies. Like all algorithmic models, COCOMO 2 requires sizing information. Apart from the lines of code and the function points, COCOMO 2 introduces the object points as a sizing option. Like COCOMO 81, COCOMO 2 uses a variety of cost drivers, scale factors, and other adjustment procedures. COCOMO 2 is significantly more complex than COCOMO 81, which reflects the increased complexity of software and application domains, a wider variety of life cycle models and software engineering techniques, and the proportional growth of software generation and reuse compared with manual programming, and the continuing nature of planning and cost estimation. COCOMO 81 was better for waterfall lifecycle models, but COCOMO 2 is much better for iterative lifecycle and object-oriented programming. It recognizes the prototyping, increment, short cycle use of programming generators, development by component composition, and so on. COCOMO 2 is more relevant to modern projects. There is a lot more complexity associated with COCOMO 2, and this module's reading is about COCOMO, so make sure that you have a look.
And that's it for this video. We talked about estimating costs, schedule-driven cost estimation, algorithmic cost estimation, and various forms of COCOMO and cost drivers. If you have any questions, please ask, and thanks for listening.